Hey everyone, in this video we're going to finish talking about our inverse functions, and we're going to be finding the inverse of a function defined by an equation. In the previous videos we did the other objectives here. Alright, so jumping right into our example, find the inverse of this function 3x minus 5, and then graph both functions on the same coordinate axes. Alright, first you do want to verify that the function is one-to-one, because only one-to-one functions have inverses. And if you think about this, if I just pick any number for x and I plug it in to this function, it's going to get multiplied by 3, and then minus 5 gets subtracted. So any one x is going to produce a different y. The other way to think about this is that if you graph it, it's going to be a slanted line. So this is in fact one-to-one. So we can go ahead and move forward and do our steps for finding the inverse, and we'll summarize these steps in just a minute. So first, where you have an f of x, go ahead and put a y. So you have y equals 3x minus 5. And now this is the step where you have to think about inverse as opposite. So you're going to swap or interchange x and y. So this is the step where you say, okay, I'm finding the inverse, so I'm going to swap x and y. I'm looking for the opposite of what I had, so switch or interchange those variables. So if you remember what you're doing, you're finding an inverse, hopefully that step comes naturally to you. I want to find the opposite, so I'm going to switch x and y. Now, this is the answer. However, we rarely leave the answer like this. This is implicit form. So we want to define it explicitly. We want to solve for y. Okay, so we're going to go ahead and solve this same equation for y. Just a couple of steps on this one. And we're going to add 5 to both sides. Okay, so you don't necessarily have to rearrange, but if you want to, you can, and you add 5 to both sides. And then notice the last step is to divide by 3. So you can write that as y equals x plus 5 over 3 like this, or you can write it with a fraction 1/3. And both of those are the same thing. And this is the inverse of our original function. So at the very end, what you always want to do is you want to put your inverse notation back on. So even though our answer was here with a y, go ahead and put in your inverse notation. Say that this is f inverse. This is the inverse of the original function, which was f of x, which was 3x minus 5. And a kind of a way to make sure you're on track, and this is not always 100% the case, so just it's just a good check, but still do your algebra like this. It's just sort of visually to take a look at what's happening. Originally you were timesing by 3, you're multiplying by 3, and now you're dividing by 3. And originally you were subtracting 5, and now you're adding 5. So that's sort of a quick way to just make sure like things look like they're opposites. Alright, so we verified that these two functions are inverses of each other, and then we'll graph them. Okay, so if you want to graph it as y equals, that might be easier because this just looks like a line. So remember your slope-intercept form, y equals mx plus b. So this is a line with y-intercept at -5, right down here, and then a slope of 3. So you're going to rise 3, and run 1, and plot that point, rise 3 and run 1, and so on. And then that is the original function f. And so the inverse is the opposite. You can graph this one on its own. You can say that this is 1/3 x plus 5/3. But what would be easier, since you've already graphed the original, is just go ahead and mirror the points. So swap x and y. If this was 0, -5, then -5, 0, which is about right here, is going to be on that graph. And then so on. 1, -2 means -2, 1 is going to be on that graph. And so this is the inverse function. And they always mirror about this line. They are always symmetric about the line, y equals x. So this is the original graph, and its opposite. Alright, so here's the steps summarized for finding the inverse of a one-to-one function. First, you want to go ahead and replace f of x with y, just so that it's easier to work with when you do the very next thing, which is to interchange the variables or swap x and y. So that one, just remember you're finding the inverse or the opposite. So you're going to swap x and y in your equation. Okay, and then that's actually the answer. That is your inverse function, but it's defined implicitly, and you want to go ahead and solve that for y. So in the next step, you're going to solve for y, and then that way you get your inverse function. And then don't forget, put your inverse notation back on. So after you solve for y, you just say f inverse of x equals whatever it is that you got. And then step 3, you can always check your results by doing the composition, which we talked about in the previous video. So if you compose f inverse of f, you should get x, and the opposite, compose f of f inverse, and you should get x also. And if you do these two things, then you know for sure that you didn't do anything incorrectly in your work, and that the two functions are in fact inverses of each other. Alright, so how about this one? So this function is 1 to 1, and we have to exclude 2, because if we plug in 2 here, this would be undefined, dividing by 0. And so find the inverse, and then go ahead and check the results. Okay, so let's go through this one. So first, where there's a y, f of x, put a y, and next swap x and y. Okay, so everywhere there's an x, you're going to swap it. You're going to say, okay, this is now y, this is y, and then this is x. And now you want to solve. Okay, so solve this equation for y. You did the inverse step, you swapped x and y, and now we're going to solve for y. And so what you want to notice here is when you're solving for a variable and it's in the denominator, it's also in the numerator here, but if it's in the denominator, you want to multiply by the denominator. Okay, so anytime you're solving an equation and your variable's in the denominator, go ahead and multiply both sides by that denominator. So what's going to happen on the right is this is going to divide out, and on the left we just get x times y minus 2. And then we can distribute the x here. And now notice what you have. You have y on one side of the equal sign and also on the other side. So anytime you're solving for a variable and it's on two sides of your equal sign, get them on the same side. Okay, so you want your y terms on the same side, because that's what we're solving for. So get both terms with y on the same side. For us, we're going to subtract y from both sides, and at the same time we're going to go ahead and add 2x to both sides of this equal sign. Okay, that way what we're solving for is all by itself on the left and everything else is on the right. And now the last thing is, if you're solving for y, you need just a single y. So what you have to do is you have to say, well, this term has a y in it, so does this term. So I'm going to take the y out of both of them. So if you take out y, if you factor it out, notice what's left. You're left with x here, and then invisible -1 here. And so that's why that factor is here. And if you want to check your work, just go ahead and distribute this back in, and you'll get exactly where we just came from. Y times x minus y times 1. Okay, let's erase all this so you can see what's happening. And now, last step, solve for y, which is just to divide by what's happening to it. So y is getting multiplied by something, so all you have to do is just divide by that factor. So divide both sides by what's multiplying your y value, and then that's the answer. So then what you want to do is you do want to put your inverse notation on. So that last step would be f inverse of x is your result. 2x plus 1 on top, x minus 1 on bottom. And on this one we have to exclude 1 because we can't plug in 1 here, or this would be undefined. Okay, so that is the inverse. Okay, so now let's go ahead and check. Let's check our work. We didn't do anything incorrect, so this is going to work, but I just want to show you what this looks like when we check. Alright, so you are plugging in the original function into the inverse function. So the inverse function, f inverse, is what we just got at the end here. It was 2x plus 1 over x minus 1. So we're plugging in right here in these two spots. So 2 times what used to be x plus 1 on bottom, what used to be x minus 1. And what happens after this is just simplifying. So this looks pretty ugly. And so what we have to do is we have to simplify the way this looks. Because if you remember what our goal here our goal is to show that this is x, because that means that we did our work correctly. Alright, so now how do we start simplifying? Well, what we can do is we can notice that we have a fraction on top, a fraction on bottom, and so you can multiply by the denominator. So x minus 2 times the whole numerator, and then on the bottom, x minus 2 times the whole denominator. And we're allowed to do this because technically this is 1. Anything over itself is 1, so this is just a funny looking number 1. Okay, this is a very strange number 1 that we're going to multiply by. So we're going to distribute x minus 2 to both of these terms, and same thing here, distribute x minus 2 here and here. And so in the fractions, the x minus 2 is going to divide out because of that denominator, but then we have to distribute, so then it's times 1 over here in the back. So let me go ahead and just show you that really quick, so in case you're getting confused on what is getting divided out here. So we had x plus 1 on top, x minus 2 on bottom, and we distributed the x minus 2 there and also back here. This is just the numerator. Okay, so that's just the top. So the x minus 2 got divided out here, and then it got multiplied by positive 1 here. And so that is why we have 2x, so if you distribute the 2, that's why we have 2x plus 2 right here, plus x minus 2. And very similar on the bottom. And then if you combine like terms, you have 3 x's on top, so 2x plus another x. And then on bottom you have 3, and then that is just x, as long as we exclude 2 from what we originally could plug in. And that's good news, that's what we wanted. Okay, let's go the other direction. Now we're going to plug in the inverse function into the original. And so the original, let me write that down for you again. F of x was x plus 1 on top, x minus 2 on bottom. So we are plugging in right here and right here. And the goal, after we simplify, is also to get x. Okay, so we're plugging in to that spot on the top and that spot on the bottom. So to start simplifying, we do the same thing we just did on the last version of this, the other direction. Notice that the common denominator is x minus 1, so I'm going to multiply the whole numerator by x minus 1 and the whole denominator by x minus 1, and watch when I distribute. So when I distribute here, this is going to divide out with the bottom x minus 1, and then I'm going to distribute here. On the bottom here, and I'm going to distribute here, it's going to divide out with the denominator, and then I'm going to distribute here. And so that one on top, notice we have 2x plus 1, and then plus, it was 1 times x plus 1. On bottom, we had the 2x plus 1, and then minus 2. When we distributed, it was minus 2 times x, which is here, and then minus 2 times minus 1, which is plus 2 from distributing. And then just combine like terms and simplify, and you'll get x. So that means that we did everything correct. These two were in fact inverses of each other after we did our few steps of swapping x and y and solving for y. Okay, last one. We're going to find the inverse of a domain restricted function. So find the inverse of f of x equals x squared plus 1 if x is greater than or equal to 0. So the reason for this is because x squared plus 1 is not 1-to-1. So this is not a 1-to-1 function originally, but if we go ahead and say we only want a part of the domain, then we can make this a 1-to-1 function. Okay, so if you think about it really quick before we start finding the inverse, this function, x squared plus 1, is a parabola. So it's a parabola like this one here. And notice this is not 1-to-1. It would fail the horizontal line test. Watch, if I just draw any horizontal line, it's going to fail. It's going to hit twice. Okay, so this is not 1-to-1. But if I say I only want half of this function, I want to cut off anything less than 0, if I don't want this, then if I only keep this side, then it's 1-to-1. So that's what we're doing. We're restricting the domain to 0 or greater, and so this is now a one-to-one function. For every one x, there's a single y value on the graph. Okay, and that means we can go ahead and find the inverse. Okay, so we're going to go ahead and do our steps, and we want to put a y where there was an f of x, and then swap x and y. Okay, so swapping x and y, and now we just solve for y. Right, so if we solve this for y, it's just a couple of steps. Subtract 1 from both sides. So we get x minus 1 equals y squared. And then you'll take the square root of both sides. Now, anytime you take the square root, you should technically put a plus and minus. However, because this was restricted, okay, so originally our domain was restricted, but when we did our swapping, now y is restricted. That means we only want y greater than or equal to 0. So we only want the positive version of this. So then that gives us just y equals positive square root x minus 1. And so that is our inverse function. Alright, so let's go ahead and check our work. So f inverse composed of f, plugging in the original into our inverse function. So let me just write down the inverse again. F inverse was square root x minus 1. So we're plugging in right here. So we're putting in this original function right into that spot. So here's the original function inside the square root and then minus 1. Simplifying, we get square root, so right in between here we could add a step. We could say square root of x squared, which the square root undoes the second power, and we get x. But because this is always going to be positive, if we square something and then take the square root like we did, we're just going to put the absolute value bars just to maintain that it's always positive. Okay, and so that's just x. Now we go the other direction. Go ahead and plug in the inverse into the original. And so the original, let's just write that down. The original was x squared plus 1. And so we're plugging in right here into this spot. And so we're taking our inverse and we're squaring it and adding 1. Okay, so square the square root, and you get in between here, we could say that we got x minus 1 and then plus 1. And that's why it's just x. So yay, those were correct. Both inverses of each other, we did that right. And so the last thing to mention is just the graphs. Okay, so notice when we graph them, here's that half of a parabola. Here's our restricted domain parabola here. And then if we graph this square root function, it's actually this one here. And then if you notice, these are in fact symmetric about the line y equals x, which is another way to verify that they are in fact inverse functions of each other. Alright, so that's it for this one. Thanks for watching.